We're gonna open up the scope here. Oh, back up, sorry. 2-channel, I wanna use 2 channels. So I have 1 channel that's gonna be our amp clamp, low current amp probe. We're gonna be reading it on the 10 millivolt scale. Up to 60 amps, 10 millivolts per 1 amp. And channel 2, which is just gonna be our positive lead measuring our battery voltage. So we got our battery voltage change over time. You can see we have a green trace and a yellow trace. That's channel 1 and channel 2. Channel 1 is yellow, channel 2 is green. So let's get it all hooked up and see what we got. Clamp hooked up on the battery charging cable. We got our channel 2 lead on battery positive. Just putting our voltage over top of our charging current. Checking for the health of this alternator. We can see that down here we have our minimum on channel 1, which is the amp clamp. We have our minimum voltage of 0.03, maximum voltage of 0.55, and our current voltage of 0.27 millivolts. Now the millivolt reading is actually what's being measured in amperage, because if you remember before, it was 10 millivolts per amp on the scale that we're using to measure the current coming through that wire. So with the truck running, you can see that we have our amp clamp hooked up. We have our channel 1 lead set to a 60 amp low amp probe, channel 2 lead set to a regular DC voltage multimeter lead hooked up to the battery. So we have a pretty consistent battery voltage. Looking at our minimum, maximum, and live voltage. So we have a lowest voltage of 13.65, an average of 14.1 that it's charging at currently, and 14.86 was our peak. So this is a little on the high side, but pretty good. Like just below 15, that it's acceptable. That's pretty strong. This is still within range as well. And you can also see that with the amp clamp hooked up on the alternator charge wire, we have our amperage waveform in the yellow, and that right there, there's some spikes. There's a little bit of inductive noise coming into this waveform that I'm not thrilled with. Now, I know the battery on this truck is weak already. It tested poorly. This is the truck from last Saturday that I did all that diagnostic inspection on before purchase. So now we're getting a little bit deeper to see if it's the alternator that's the problem or the battery or both. And as you can see, there is a fair bit of noise on this waveform, but I'm not overly concerned. We're charging anywhere between 7 and almost 40 amps with a somewhat consistent 17 amp charge output to the battery. So the alternator is definitely working. This is one test that we can do to determine the integrity of the charging system and see if there's any further action required. I'm not seeing any dropouts in the voltage as we're going along here. This is the 100 microsecond scale. So just to give you an idea, if I pull up my traces here, this is between these 2 points, not even 1 full second. That's how quickly this thing pulls samples off of the electrical system. So this is a very, very powerful tool. So now we're going to turn on all the electrical loads on the truck and see how the alternator does under load. And you can see we've ramped up to almost 60 volts or 60 amps with all the electrical loads on currently. We are fluctuating quite a bit there, in and around the 2 amp variance, but we are hitting our peak 60 amps of what this amp clamp is capable of reading. So we could even be putting out more. I would have to use a different clamp to be able to see higher output, but the alternator is definitely putting out 60 or more amps to the battery. So it is working. It is definitely working and putting out a fairly decent charge rate. So I'm less concerned about the alternator. The noise on the waveform is slightly concerning, but we even have to step up here to the 60 amp scale and we can see our waveform a bit more clearly, and that noise is still there. So with all electrical loads on, the alternator does perform and has a strong output. So we're gonna do a couple other tests on this alternator just to make sure, but it's looking like it's just the battery on this truck right now. So next up, we're doing voltage drop tests and just checking battery voltage. So switch it over to DC voltage, just digital multimeter mode. And you can do this with a regular multimeter. You don't need this special piece of equipment to do it. So just cross the battery, typical voltage test, nothing crazy. See, we got 13.13 volts. So this battery is holding a charge, and that's because we just had the truck running. So 13.13 volts, pretty good surface charge. Now we're gonna switch for the voltage drop test from positive to positive instead of positive to negative. So with one lead there, we want to see basically 0. And no change. So because with the lead disconnected, we're getting a 0.03 reading. I don't know why there's like residual voltage being read. Like right now, I'm not hooked up to anything, and I'm still getting 0.03, 0.02. So we're going to consider that our 0 point. And with multimeter hooked up, we can even drop the scale down because we're looking for less than a volt. We don't want to really have a reading on this kind of test. So we can hone in a little bit more. Back on the positive. No change. So that means there's no resistance in this wire. This is a good charging wire. No issues here. Okay, so we're out of digital multimeter. We're gonna pop into graphing multimeter here. AC voltage. I'm gonna do an AC ripple test to make sure that the rectifier bridge in the alternator is working correctly, because we want DC voltage charging this battery, not AC. So I'm gonna hook my negative to the negative, positive to the positive, and we have a bit of a voltage spike here that's just hooking into the circuit. So now we're measuring our peak 12 volts and back down to 0. So see what's going on in here. So pretty good. Obviously on startup there's a little bit of an AC leakage, but nothing that I'm concerned with. We don't want to see too much AC voltage. We're going to drop down to the 1 volt scale, and as you can see, we have, let's bring our time frame down, bring it down, 1 second. So this is basically a voltage over time graph, and as you can see on the 1 second scale, we are not seeing, this is 1 full second. So the distance of the graph is 1 second's worth of time span. We're not getting more than about a half a volt of AC, which is very good. We don't want to see anything more than, or that's not even half a volt, sorry, that's half a millivolt. So this is pretty good. This alternator passes the test. Bring it down. You can see our ripple a little bit better. Those peaks are very, very small. That's what we want to see. If we're seeing peaks that are coming up and down across the voltage span, closer to the 1 volt mark, then you know that we got a rectifier bridge problem inside the alternator. So this is another test confirming the alternator is good to go. This is one other quick test that we can do to check if the diode trio inside the alternator is working correctly or if we have any shorts is resistance test. So one channel on the negative, another channel, we're going to go across negative to negative. So just alternator case ground right there on the side of the case, and 0 ohms. That's no resistance, which would mean also no voltage drop, which means that our ground on the alternator is good to go. Now, if I take that same test and go over to the positive side, no reading. OL, or over limit, essentially. So, infinite resistance, which means there is no short circuit connection between the positive side of the circuit and the negative side of the circuit. Now, we can do the exact same test in reverse. Go over to the positive side and check the positive side to case ground, and we are over limit still. So no short circuit there either. And now we'll go positive side to the positive side, and 0 ohms. So another good circuit. This is just a different version of the same voltage drop test that we did. It gives us the same results. So essentially we're reconfirming that the charging side is good. Well, now I'm getting a little fluctuation as I'm moving the lead around. But yeah, there we go. Good connection, 0 ohms. Charging circuit is good to go.